Hello and welcome at onAIr, the talk show where we demystify AI and showcase you the latest inventions of future-proof organizations. In this episode, we will talk to the city of Amsterdam about algorithms and transparency. We will talk to the Dutch railroads, how they innovate with machine learning, and we will talk to a startup called Pandora Intelligence about how they have created a system that can predict criminal behavior and even terrorism. I hope you're ready. Let's begin. In the studio with me here today is, first of all, Maarten Sukkel, AI lead for the city of Amsterdam. Welcome.
Yes, thank you. Great to be here.
And also Leo van der Meulen, product owner data and analytics at the NS, the Dutch railroads.
Yes, nice to be here.
So good. Maarten, first of all, let's rewind a bit. What was the first time when you got interested in AI?
First time I got interested in AI was a very good question. I think quite young. I was interested probably in video games. You would call that AI, like how are they moving around? But I think since then I have grown, but also the AI world has grown and even the possibilities in it as well. So they've become smarter, I would say. Yeah.
Leo, you have been working at the NS for over 17 years.
Yes.
When was the first time the AI virus took you by surprise?
I think during my study. I studied computer science, and already there we were developing the first versions of the neurons inside of neural networks, and it already triggered me, and data was always very interesting. So from the start of my career, data and advanced analytics and AI was very interesting.
It was a while back. What kind of tools could you create with these very first algorithms and very first neural networks maybe?
You could build very small predictive systems, not the size we're using today, but small predictive systems were possible to build. Yes.
Very good, very good. Maarten, AI lead for the city of Amsterdam. What does that mean in practice every day?
That I get to do what I love every day, and that it's like building AI for good. So basically look into all the challenges in the city, all the problems there are, and then think about possible solutions with this new AI technology. And then start diving into it, start coding and seeing what can happen and what cannot happen. And then either advise, stop with this, or be like, okay, this is interesting, let's find people to make this grow further and further. So yeah, that's a brief summary of my job.
There are working about 18,000 people for the city of Amsterdam, I believe. How many are in your team?
Yes, so my team is right now about 12 full-time people that are really working on, would say, like state-of-the-art AI. We also, of course, have much more people working with data in the city. So I think 80 people would call themselves data scientists, also doing things like analytics a bit more. But that's like the core team is right now is 12 out of 18,000. That still seems small, but I think it's quite substantial for a government to have people working on that. And we also work a lot with universities. So myself, I'm also, it wasn't in the intro, by the way, but I'm also doing PhD research next to my job. But we also have about 25 master AI data science interns working with us full time, actually all researching projects as well. So it's quite big, I would say. It was bigger than a few years ago.
Can you tell us a bit about the innovations that you're working on at this moment?
Yes, so I think one of the first examples is customer services, where we can route service requests to the right department. So somebody's walking through the streets and sees garbage, for example, instead of having to call us and say, describe what type of garbage is there, they can just call and, for example, call or text that there's some garbage next to the containers. And then the machine learning, of course, using the historical data, will be able to say, and it's very likely to be household waste. And then we know what car to send, because that's actually what it's about, that we know what solution we can send to what problem. So that's quite, I would say, well, a bit more traditional, probably an algorithm from the 70s. If you're talking, when did you get fascinated with AI? Well, that was not really called AI yet. But right now we're also going into, for example, computer vision to see if we can solve the same problem, but then by scanning the streets, by seeing what's there. Actually taking away the need for somebody to make a complaint about or ask for help, and be much more proactive about it. So
yeah,
that's
there are these cars driving around Amsterdam with cameras, and these cameras can detect if maybe there is a garbage bag at the side of the street at a time when it shouldn't be there.
Yeah, so the cars that drive around, we don't use that because, well, legal reasons. We can just start adding functionality to those. So right now what we, for example, do is we have smartphones, very cheap, attached to the dashboard of cars. And we use those to scan the streets. So that's, I think, very interesting to see how, well, in the last decade, you went from a very big camera with a lot of processing power to this tiny device that can actually do the same thing, probably. So in 10 years, maybe you won't even be able to see them anymore, how small they are. So that's very interesting to see that, and also to make sure that we as a city are ready for this new technology. And it can actually, for example, use edge processing to scan the streets, which makes it all a lot easier.
In a bit, we'll talk about data and transparency and even the algorithm registry you've created. But first, NS Leo, what kind of inventions are you working on at this moment?
At this moment, with my team, 12 is the magic number today. I have a team of 12 data scientists and data engineers. And we are developing models for prediction of crowdedness. So how many people will take the train tomorrow or the day after, and how will they be seated in the train? We started 4 years ago with determining the spread of people in the train. We got a lot of complaints. There is no place to sit in the train. When we looked at our data, we saw there should be enough space. Yeah,
but everyone wanted to be at the same.
Everyone wants to sit at the same place
yeah.
in the front or in the back of the train. So we invented the seat finder, and what we saw. I think March last year, March 2020, the prediction model we had for the number of people in the train stopped working. In one day, we lost 90% people when the minister said it's not allowed to travel anymore.
Yeah.
And we saw these models were still predicting the old number of passengers. So we looked at that situation for a couple of months. First, we thought it's a lost year for data science, but we decided, no, we have to build a new model. And so we looked at the data we have, especially around our customers, check-in, check-out, and we have developed a model that predicts the crowdedness of tomorrow. We did it 5 to 7 months in front. Now we're doing it for tomorrow, and even during the day, we're improving the predictions of crowdedness.
So actually, due to the pandemic, your models have gotten more accurate, actually.
For the current situation, they're more accurate. The old models are not accurate anymore, but we build models that are more adaptable to what's happening outside. The old models didn't think about situations where there was a press conference saying, start working from home. So it's 5 months in front. Now we're still looking at the last few days and all the trends we see in those days, and even during the day itself. Those are used to predict further ahead. So we can manage the pandemic, and probably we can manage something that's going to happen in a few years, which we don't know it's going to be.
Maarten, did you had the same experience as well? Did you thought that it was a lost year for data science when the pandemic hit?
Well, there was also still a lot of work to do. I think so for data science, for the work, there was more work because all the predictive models broke. If you're predicting the future on the past and something that is occurring that never happened, at least not in our data sets. Of course, there were other pandemics, but this was quite a new situation. Also, all the models we had for predicting like how busy it's going to be tomorrow or how busy it's going to be next year, they all broke
places
down.
is one of the things you're working on?
Yeah, that's a bit of a different one, but also very likely to be influenced by this because, well, if suddenly nobody's going outside anymore, well, there's not going to be a lot of crowdiness. So we had the same issue, and we also went to more short-term predictions and adding in features like, for example, the weather was always a very strong element in how if people go to a park or to a pub. But with COVID, it added even more. But we also added, for example, the stringency index, like how strict are the rules in certain areas. And we would actually, adding that information would make the models better.
Leo, what kind of data points are you looking at for your prediction models?
When you look at the spread of people in the train, we're looking at the weight of the train. When the train rides over the tracks, at several places in the country, the train is weighed by the system. We use this to determine the spread of people in the train.
Really? So,
yes.
you know the basic weight of a carriage?
Yes.
And then if it's heavier, you predict that maybe the average human is 80 kilograms or something like that.
That's the step we don't do.
Okay.
That's the first question everybody asks. What we say is when one carriage has 200 kilograms of passengers and another has 400 kilograms, that's the same way the people will be distributed.
Okay.
So we know there are 200 people in the train, and based on the weights, we spread them. So it's a relative model. It's not absolute because there is no standard passenger. A school kid has a different weight than somebody going to Schiphol to take an airplane.
Now, you could say that you just put up a camera, a very cheap smartphone in the train carriage, and you count it by scanning faces, for example.
Yeah, it should be. We're looking also at it because there are cameras in the train. but there's a privacy related to using camera images. So we're looking at the data that's coming from the train we can already use, like carbon dioxide levels.
Yeah.
When there are more people, carbon dioxide goes up. So we can also build a relative model based on carbon dioxide. We're looking at the usage of Wi-Fi in the train. How many people are using it? So we're using different indirect data points to estimate the spread of people in the train. And when we look at our prediction for tomorrow, how many people will go to, for example, Zandvoort, we use our check-in, check-out, of course. It's a very rich data set, but also the weather, especially towards Zandvoort. When it's 30 degrees, it's sunny, people go to Zandvoort. So we build this very relative simple model that's added to the big model just for Zandvoort to increase the number of people when it's sunny.
In a few moments, we will hear from AI expert Martin Haaghoort about his famous AI column he does every episode of OnAIr. But first, we took our camera onto the streets to university campuses and asked data science students what they think of AI in government and public services. Let's take a look.
If the government is going to be involved, I would say just don't do it. But that's more a political opinion about my government.
Well, if we choose for machine learning algorithms to determine certain actions the government takes, they should be heavily monitored. Machine learning algorithms have been shown in the past to be incredibly racist and prejudiced. Basically the thing they are designed to do is to discriminate, which is somewhat, on the contrary, what you want as a government.
If the government has a better understanding of what is happening and how it's happening, then we can make the benefits bigger.
AI can definitely reduce the amount of human errors are made. We have shown that pathfinding algorithms for example, trains with ProRail, when they have to create a new track or create a new service schedule, computers are already more efficient at it. They just find better solutions.
Humans tend to miss something, an algorithm might not. Especially if humans have to do a lot of the same work, they just get repetitive and they just lose focus. So I think algorithms could actually improve that a lot. But I also think that if we over rely on them, we stop checking them, because in the end our algorithms tend to have the same biases as humans, because the data we feed is created by humans. And so
when humans have been biased in the past, the outcome of the AI is also biased. So getting rid of that is just super difficult, and I think it will take a lot of effort to get the human factor completely out of AI.
So these were the data science students, and they kicked off Maarten by saying AI in government, don't do it.
I think it's. I could arrive at the same conclusion as well, but at the same time, I would say AI is going to be so crucial, and also the other points they mentioned about the issues with bias in AI and also the huge benefits it could bring. I would say we should really, as a government, get more expertise on AI and actually be able to see the difference. So. Be very transparent about it. Be sure that there's no bias. Actually, try to make a step to a more fair society using them. Because they also mentioned it's very difficult. I agree with almost all the points they made, but I come to a bit of different conclusion: is that we should invest in it.
Maybe invest even more.
Much more, because it will change every aspect of people's life. So let's make sure that this time we're not, as a government, too late with investing. As you see with a lot of digitalization, IT, what happened. Let's be on the forefront this time and actually invest much more than we are doing right now.
Now, the city of Amsterdam is quite a wealthy municipality. There are also smaller cities in the Netherlands, villages. How can they also get up to speed with this kind of technology if you don't have a team of 80 data scientists and so many interns working there?
It's a funny question, because this one time I was talking to a professor from China, and he was talking about smart villages. At one point I asked him, why do you keep saying smart village? He said, we consider everything under 1 million inhabitants a village. So maybe like that's how you can look at it as well. We're also small, but comparing us to like other smaller cities, I would say not everybody can set up such a team because 1% of innovation budget is a lot more in Amsterdam than it is in another city. So everything we do, we also try to work together with other governments, local governments. We try to be transparent, share source code. Because if you think about it, having every city in the world, every municipality around the world researching the same things, that's not very efficient. And also when it's about making cities more livable and nicer, we should share that knowledge and we should actually collaborate much more. I would say actually you would need one AI team for all cities around the world. That would be like my perfect situation. So let's work together, I would say. Yeah.
Leo, one of the students said that AI can reduce human error. Do you agree with that statement?
Yes and no. I think when you look at repetitive tasks, it can be better than a human because it's predictive. It will do always the same. When you have trained a model or an AI system to perform one task, does it do something else? No, it won't do any better than the human being. So yes and no.
Now, bias. How can we get rid of these biases?
I think it's very important that we know there is a bias in our systems because it's not in our blind spot, so we know it's there and we can start solving it. And we need to remember that the bias of the developer is the bias that the model will make bigger. So thinking at the beginning when we start building the models, finding the right features to feed into the model, the right test data, the right validation data, when we look very carefully at that, we can reduce bias. If it can be removed completely, I don't think so, but you can get rid of a lot of it and have less bias than a human.
Maarten, the city of Amsterdam published an algorithm registry. Can you tell us what it is and what do you want to accomplish with it?
Yeah, so that's a collaboration we did with Helsinki. So we really like working together with other cities as well. And the whole idea behind this is that there's all sorts of algorithms having influence on people, their life. Or it can be an algorithm that decides to what school you'll be sent, where you can go at least. But it can also be something, a routing service request, or something that might give you a parking ticket, a fine. So what we figured out is the first step we need to have in order as a government to be accountable for our mistakes is to be very transparent about what we do. So the idea behind the register is that actually all the algorithms that have influence on people, their lives, are described and what data is used, what risks are there, what methods are taken to mitigate those. So it's actually a first step in being much more transparent about the work we're doing with the algorithms. And hopefully make sure that when there's mistakes or bias in these algorithms that we haven't noticed yet, that also people can notify us about it, so we can actually fix it instead of having to wait for journalists to really dive into what happened, and make that a lot easier and able as a government to more swiftly fix mistakes and also prevent any negative effects on our inhabitants.
Now let's take a step back to the daily practice again, Leo. When you start out with machine learning projects, it's often that you have a lot of failed attempts before something starts to work. You have to be very lucky if you're right at the first shot. Can you share an example of an experiment that you did which didn't work out?
Yes, for our crowdedness prediction, we wanted to use the travel planner, the usage of the travel planner, because people go to our website, to our app to plan their journey. And we thought that's going to be a very good indicator of the crowdedness. But what we saw is that there are a lot of automated systems out there in the world continuously questioning routes at our planner. So as, for example, in the middle of the night, thousands of people seem to be requesting journeys. Nobody's traveling at 3 o'clock. Only a few people. So we thought it's a very good source, but in the end it seemed to be there's a lot of noise in the data because a lot of automated systems at companies. I saw a screen here that says the departure times. All those systems are interfering with that data source. So we had to go back to our check-in, check-out data.
Yeah, sounds like something that you can relate to, Maarten.
Yes, yeah. Sometimes like data sources where you think this is going to be great actually ends up not being that good. Actually, we call them data morganas. So
data morganas.
Yeah. So you're like, okay, there's this great data set. Everybody's always mentioning it. Oh, we can use that. And the moment you really start diving into it, either you notice like it's not registered properly, or it's actually not a good feature at all. So it's very familiar. We actually have a word for it.
We even build a process around it. We start with an explorative analysis from, hey, is this data source usable? Then we go to a proof of concept, and only then we start developing the most minimal viable product. just as soon as you can find out if it's a data morgana. I like the term. Yeah.
Now, in a bit, we will look at the AI landscape in the Netherlands. We look at the Dutch AI Coalition and its hubs. But first, we take a look at AI expert Maarten Hagoort, who wants to debunk a common myth about artificial intelligence. This time, he will answer the question, is AI going to make things easy?
Is AI going to make things easy? Sometimes it appears that AI is a solution to every problem that we have. And, it seems like there's only success stories in the realm of AI. And of course, the question we cannot generally answer, of course there will be situations, and we already see those situations where AI is really making a difference. So there's a lot of great progress being made by applying AI. But as with every new technology, there's also quite a number of failures. And they're not really publicly advertised. And I think it's important that we realize when it is working and when it's not working. It's very attractive to talk about success stories. It's not so attractive to talk about failures. As we've seen with the e-commerce boom, as well as with the CRM surge at the start of the century, more than 80% of the investments actually fail. I think it's important that we realize that is also the situation that we're in right now. Many tech platforms make it sound that, it is easy. And, that sometimes tools are free, sometimes platforms are free, even data is open, algorithms are free. So, okay, it seems to be available. And it gives the impression that it's easy to use and apply. There's a lot of work that needs to happen in order to make it work. Everyone realizes it requires investments, but time is required, experience is required, and you might almost conclude that failures are required to learn and progress. So no cookie cutter approach. You need an innovative mindset, you need the financial means, time, and in particular, hard work.
Yeah, that was AI expert Maarten Hagoort. There's no single solution. Companies need to invest to build skills and competences. That goes for governments as well. But then again, where do they start?
Yeah, where do they start? Well, what he said about 80% will fail, I think so, and I probably that's also a good thing. We don't want every AI solution to have a large influence on the world. But I think the most important thing is what 20% is going to be successful. Let's make sure that 20% that is successful and operates at a large scale is going to be beneficial to society. Coming back to your other question,
It was how can people within governments who want to reskill themselves or want to learn about algorithms and AI, where can they start?
Yeah, well, I don't know where they can start, for sure, but I don't know they can stop. Because with the speed that has been, actually developing like AI and how easy it is to implement, I think it's going to be more accessible for everybody very fast. Like 10 years ago, you would need to have very specific programming knowledge. Now I think most, average programmers are ready to start some proof of concept, make some models. And you already see a lot of platforms coming up where you actually can use drag and drop and already get started. Not you can't make anything with them, but you can make more and more like that. How do you keep up to speed? I know there's some courses you can take, like from the Dutch AI Coalition. They do this for business as well. Not sure if that's already announced. So where you can start learning. I think that's the most important thing, just to start playing around with it and start making small mistakes before you start doing really big projects and make big mistakes.
Yeah, we're going to look at the AI Coalition in a second. Last question for you, Leo. Do you think that the 22,000 colleagues at the NS all need to know the basics of AI in the next few years?
Very good question. I think it will be useful to understand the core competence of what AI can do for you, because it will be everywhere. You need to understand the system that will be introduced into your work. What's it doing? What's it predicting? Is it working or is it not? Because it will not always work flawlessly. So yes, I think a lot of people will need to have a basic understanding from what it's doing and what it can do for you. Not everybody has to be able to build models, but understanding the basic principles, yes.
Yeah, thanks. And in a bit, we will be joined here in the studio by the managing director of Pandora Intelligence, a startup that creates neural networks to predict criminal behavior and also terrorism. But first, we take a look at AI in the Netherlands, because there's a lot of innovations and a lot of initiatives going on. And to coordinate all these efforts and to keep everyone aligned, the Dutch AI Coalition has been a key pillar in the ecosystem for the last 2 years. And they can't do it alone, so they've created all these hubs within the Netherlands. So we took our camera and we went out to the high-tech campus in Eindhoven.
The mission of the Netherlands AI Coalition is to stimulate, orchestrate and where necessary organize the development and application of AI in the Netherlands. And it's particularly the application of AI that will create the largest economic impact. This is really a matter of working along the value chain. So it's very important that we connect to initiatives in the Netherlands, and particularly the small and medium enterprises and startups. You'll have to visit them instead of asking them to visit you. And that's why we have established 7 hubs. And in those hubs you will see lots of activities on horizontal subjects, in knowledge, in creating ecosystems, in education, in investments. And in those hubs we connect parties that are much more localized, and we bring them together on a national level in the coalition.
We're part of the Brainport AI Hub, which is one of the 7 main hubs of the Dutch AI Coalition and the Dutch AI ecosystem. And we are, as AI Innovation Center on the high-tech campus, a landing spot for all kinds of activities in this Brainport area. So we focus, for example, on education and events, hosting them here in this space where we are now, bringing together the local ecosystem or the regional ecosystem, and providing an infrastructure for companies to get to know other parties, get the right talent in order to, in the end, apply AI in their business context. So the AI Innovation Center is an initiative by the high-tech campus, supported by ASML, Philips, Signify and NXP, big companies in this region, with the mission to industrialize AI in the Brainport-Eindhoven region.
We have a chance to develop the next generation of artificial intelligence to learn what we see go wrong in the other regions of the world. What we envision is that we're going to help a lot of our startups into the next phase and become successful companies out there in the world. And besides that, they have a good financial return at one point, that they also create societal return as we are an impact-driven fund. And that's also why we always say good things are coming.
We have on this campus over 80 startups, also a lot of international companies. By bringing them together, new ideas come up, and these are the ideas and the projects that make the difference in the end.
We are Autoscriber, and we've developed software that listens in to the conversation between a doctor and a patient. And it can then help to fill out the electronic patient file completely automatically. So the doctor will not have to take all those notes and can therefore focus more on the patient. Our ambition is to save at least 50% of the time that doctors spend behind the screen. We have currently integrated this with the major electronic patient files, so we're kind of ready for a hospital to start using the software as of the beginning of next year.
Now, some social challenges are so big that government organizations can't develop solutions by themselves. But luckily, there are startups and scale-ups to help them out. And one of them is called Pandora Intelligence. And they use large-scale neural networks to help police forces and intelligence agencies to predict suspicious behavior and even terrorism. To tell us all about it, we have in the studio Managing Director Art Jol. Art, welcome.
Thanks.
So good that you could join us here today. Tell us, what is Pandora Intelligence?
At Pandora, we aim for making the world a safer place. And what we do is we combine data science with storytelling, basically. And by doing so, we are really able to anticipate crime. So we never talk about predict, but anticipate. So that's what we do.
Can you give us a practical example of the work that you've been doing the last few years?
Yes, definitely. What we do is we look to data through the eyes of narratives, which means that if you look to books and films that you can look in the cinema or you can read, it's all scenarios. It's been thought of as a scenario, And these type of scenarios we can use in real time to look to situations that happen today. So if there is, for example, a 911 call or an 112 call, if you can look to have we seen this before? Are there elements inside that we recognize as part of a certain narrative? Well, we can help services to anticipate what might be the most probable scenario and next step.
So you take, for example, Casa de Papel, the famous Netflix series on a bank heist. And you take these elements and plot them into the real world scenario where maybe someone is calling from a bank heist and seeing if there is some correlation over there.
It can be a case, yes. So, and as there is a lot of data available in cases that have been thought of, like movies and also book scripts, there's a lot of creativity inside. And what we know is that criminals are most often not as innovative as we think. They learn from what they've seen and what they have heard in the past.
Yeah, so because some people might say those movies or those books, they're all based on fiction, so you can't use those data. But you say they have been inspired. Everyone has been inspired on some level by these situations.
Yeah. So what did George Bush do when 9/11 attack took place? He really invited Hollywood to think about the next scenario. And I think that's a good example of how that type of data could be of use in real life.
Can you name some of the clients that you've been working on?
It's not that all our clients are working with this type of data, right? So we look to all kind of open source data sets that are out there, and depending on the client and the type of client, we define what to use and what not to use. But clients we have are in the public sector, police, but also Ministry of Defense, for example. And also in the private sector, we work with airlines and other accountants and notaries. And that's more specific on looking to scenarios that relate to AML, CDD, that type of
anti-money laundering,
exactly.
And that sort of thing.
Customer due diligence.
Yeah.
Yes.
Martin, what do you think about these kinds of innovations?
Of course, interesting, like making the world more safe. I would be not the first, I would say, not the first to say that's a great idea. But of course, when we've been talking about bias as well, that's also like when it comes to law enforcement or things like that, I should say we learn from the past, but of course, the data is also registered in the past. So is there anything maybe I will ask a question. Is that okay?
Yeah, sure.
What type of things do you do to actually prevent bias from happening when you do this type of work?
Now, first of all, per client, we define what we can use and what we cannot use, right?
Mm-hmm.
So fiction is really nice, but it's not applicable in all cases. It's only a few I can mention where you can use it, and terrorism is one of them, and cybercrime is really interesting as well. If you look to the way we approach a project with a client, we first of all look to what type of source do we use and what is the reliability of it. So fiction is really interesting. So it's interesting to take into account. But if you would take all your decisions upon fiction, I would say that's not a really good idea. So it's a mix of closed source, open source, and maybe even creative data that you use to make an analysis. And first of all, we never make a decision. What we try to do is to help with data science and the computer to really fast aggregate data and make sure that we do what a computer is really good at to do, and that's bringing all that data together and make an analysis and bring it to the experts to really take the decision. Because people are still better with their stomach feeling and all the experiences. You cannot find that in a machine yet, right? So.
Do you have an example of what kind of data you're looking for as well? You named open data sets. What kind of data sets should we think of?
News for us is in almost all cases interesting to use.
News.
So if you look to customer due diligence type of solutions, you want to know whether there is negative press releases. And it's not that we say, if there is a negative press release, it's true or false. It's good to know and to bring it to the expert. But also things like Chamber of Commerce. And furthermore, it's really depending on the client.
Leo, what are your thoughts about this? Does your data heart start beating very fast when you hear all this?
A very important item was mentioned, bias. You have your famous examples when you predict criminality in a region. You send the police there, they will find the criminality. But that's the bias part. What about the blind spot? What about the things we have never seen before? How do we find them?
Now, first of all, that will always be the case, right? So everything that happens for the first time, but also there, we don't look to the Netherlands, we look internationally. What didn't happen in the Netherlands yet already might have happened in the US or in Africa or whatever. So it's about having eye on the whole world, so global vision, and also making sure that we see trends coming towards us. So there will always be things for the first time, like there are years ago we haven't heard about drones. Nowadays it's part of society, I would say. So we need to keep an open eye on all new technologies and everything that's out there globally, and then we are at least able to be close on new developments, I would say.
So you have the trends, and you can follow a trend across the globe, but the first one, the trendsetter, that's the difficult one.
That's always the difficult one, definitely. And on the other hand, it also that is really depending on the type of client. But there could be there are ways of at least seeing new trends, hitting the scene, and also you could predict somehow what the effect of it will be. But of course, this is the most difficult one, as you know. Yeah.
Now, we're almost at the end of OnAIr, but I want to know a few questions from you before we end. Maarten, beginning with you. When you look at AI and the future, the near future, so no singularity or anything, but the next 3 to 5 years, what excites you most?
Well, one of the things I think is really, especially when we have to, basically keep the city fixed and clean and safe, point clouds data. And of course, that's not AI, but of course, we need algorithms to analyze that.
Yeah.
So for Amsterdam...
You need to help us a little bit
with the point clouds.
Cloud
data. Well, a cloud of points. No.
Oh, wow.
So basically, you have LiDAR technology that's used for some self-driving cars, for example. You could see that a picture being taken of this glass, but instead of having a picture of a glass, it also has a laser which basically is seeing the depth.
Yeah.
So for every pixel, you also will know the location. Of course, with the glass, that might not work. Well, yeah, it will. So we have that for the whole city. We basically have like a 3D scan of the city, but it's like 6 terabytes, and it's like millions and millions and millions of points. We need to analyze that somehow. And that can be something we can already do with algorithms. For example, get the location of every street light and calculate the angle at which it's falling over. So we could basically query eventually for like the top 100 most crooked streetlights in the city and actually fix them before they break down. And of course, we can also do this for trees. We can see if sidewalks are still accessible for a wheelchair. So for me, that's a very exciting development that's really gonna help a lot in the work that we have to do for the city.
And there are so many opportunities. How do you select which are most urgent?
Yeah, so of course, which ones are most urgent is also something that changes a lot. You can, especially last year with COVID, well, everything was breaking down and there were other areas where we needed to work on. But mostly, I think what's important that within our organization, we have a team working on these new developments and also seeing whenever a new problem comes up, okay, what are there possibilities? But also, of course, with problems that are always there, hey, there's new technology, so maybe we can now do something. So the garbage issue has been there in the city for some time, and it has been improving as well. Becoming worse, I would say, with everybody staying home. And then we just look for new technologies that we can use to solve that. So I think that's very important to keep looking for these opportunities.
Leo, what excites you most for the upcoming years?
We have the trend of mobility as a service. So it's not only traveling by train, bus, but also by rental cars. And how do we bring it to the people? How do we give you your personal advice? What's the best advice for you? So what's your 3D image? How do we know which train do you want to take, or do you want to take the car? So how do we make it personal? With all the information we can collect about you, your preferences, your schedule, how can we give the perfect route planner with cars, trains, buses, everything?
Art, last but not least, famous last thoughts on the upcoming years.
Yeah, for us, I think the most important step we need to take is not especially on technology, because I think we can do an awful lot already. It's more about how to work closely together with government, law enforcement agencies and private sector companies on making the world a safer place, using technologies that are allowed, also within regulations, and within the legal regime of our clients, make sure that we really help them with analysis to make sure that criminality is not something we accept in society as the Netherlands, I would say.
Well, thank you so much for your insights, all Maarten, Leo and Art, for being here today. And of course, thank you for watching to this latest episode of onAIr. If you want to know more of these crazy stories about inventions in artificial intelligence, data and machine learning, subscribe to our newsletter so you don't miss any upcoming episodes. I hope to see you soon. Thanks for watching. Goodbye.